All right, let's dive right in. Today, we're exploring a perspective on climate that, well, it might challenge what you think you know. We're going to look at the story of our climate from a pretty different angle, based on the source material for this explainer.
So let's start with the question that kicks this whole thing off. What if the story we're all used to hearing about climate isn't the complete picture? It's a bold way to start, for sure. It's designed to make you stop, take a breath, and really think about the foundations of this topic.
And you know, this quote really gets to the heart of it, doesn't it? The whole conversation around climate can feel intense, overwhelming even. So the goal here is to just step back from all that noise and look directly at the facts and arguments that this particular source brings to the table.
Okay, so here is the central, most crucial idea from the source. The very notion of a stable or normal climate that we've somehow broken, it argues that's a fundamental misunderstanding. If you look at Earth's 4.5 billion year history, you see one thing over and over: change. Constant, relentless change. The climate is a dynamic system, always on the move.
This timeline really helps put things in perspective. I mean, back when dinosaurs roamed, the planet was way warmer. But here's the real mindbender the source presents. We are, technically, living in an ice age right now. Yeah, I know how that sounds, but according to this text, the definition of an ice age is simply a period when Earth has permanent ice at its poles. And we do. We're just in one of the warmer spells, a phase they call an interglacial.
So, if the climate is always in motion, what's driving the whole thing? The source tells us to zoom out, way out, and look at two absolutely colossal forces of nature. These are the long-term architects, the giants that it says have shaped our climate for eons.
The first giant is plate tectonics. We're talking about the continents themselves drifting around the globe. This isn't just about earthquakes. The source claims this is the master switch for climate over millions of years. For instance, it points to when the Drake Passage opened up between South America and Antarctica. That single event created a new ocean current, which completely isolated Antarctica, cooled it down, and kicked off the ice age we're still in today.
The second driver works on a faster but still immense timescale. We're talking tens of thousands of years. These are the Milankovitch cycles. You can think of them as subtle, predictable wobbles in Earth's orbit and tilt. Now, the source explains that these cycles don't cause an ice age, but they set the beat. They're like a celestial pacemaker, dictating the rhythm of the deep freezes and the warm thaws, like the one we're in right now.
So let's just break that down to make it super clear. According to the source's framework, you've got two forces playing two different roles. Plate tectonics is the big one. It flips the switch that determines if we are in a major ice age or not. Then, once that switch is flipped, the Milankovitch cycles take over the tempo, setting the rhythm of the warm and cold periods inside that ice age.
Okay, now we get to what is probably the most contentious part of the source's argument, a new look at carbon dioxide. It really wants us to shift our thinking, to see CO2 not just as a pollutant or a villain, but as a vital, fundamental part of life on Earth.
And this chart really drives that point home. I mean, just look at it. The source points out that CO2 is what we call a trace gas. It's just 0.04% of our atmosphere, a tiny, tiny sliver. Almost all the air we breathe is nitrogen and oxygen. And this context, this sense of scale, is absolutely key to the argument that follows.
So, building on that, the source lays out a few key points about CO2's role. It states that at current levels, it's not toxic, but more than that, it's essential. It is literally the food that all plants eat through photosynthesis. The source argues that more CO2 has actually led to a global greening effect and has seriously boosted crop yields around the world, something commercial greenhouses have known and used for years.
Now this is where things get really interesting, kind of like a chicken or the egg problem. The source argues that the relationship between CO2 and temperature isn't a simple one-way street, and the oceans, which hold the vast majority of the planet's carbon, are right in the middle of this complex dance.
And this quote is the crux of its argument on this point. It says that when you look at the historical record, CO2 levels tend to rise after the temperature goes up, not before. The logic they present is pretty simple physics. Warmer water can't hold as much dissolved gas. So as the oceans heat up, they release CO2 into the atmosphere. This totally flips the script, suggesting that temperature can be a cause of rising CO2, not just an effect.
And that idea leads us to the final act of this explainer.
Here, the source zooms in on the 20th century and presents some data that, in its view, frames the whole relationship between temperature and CO2 as, well, a puzzle that's far from solved.
Okay, so check this out. The source splits the 20th century into two halves. In the first half, from 1900 to 1950, CO2 went up by about 15 parts per million, and the planet warmed by about ½ degree Celsius. Makes sense. But now look at the second half. CO2 levels skyrocketed, going up by 55 parts per million, nearly 4 times as much. But the temperature rise? It was about the same, just another ½ degree. The source presents this as a major inconsistency.
And to deepen that puzzle, the source adds one last piece of data. It notes that for a big chunk of that second half, from about 1950 to 1980, global temperatures didn't really go up at all. They pretty much flatlined. And this was happening while CO2 in the atmosphere was continuing its steady, uninterrupted climb. It's the central mystery that the source wants us to think about.
So, we end up right back where we started, with a question. By walking us through Earth's massive natural cycles and pointing out these complexities and puzzles in the more recent data, the source material isn't really giving us a final answer. Instead, it's asking us, is our picture of the climate truly complete? Or are there still big, fundamental pieces of this puzzle that we've yet to put in place? It's a question meant to spark curiosity and to keep the conversation going.